Here we are on chapter 17, and chapter 17 we know is all on water. So this last little section is on hydrates. So here are some definitions for you. Water of hydration, which is basically what we call the water of crystallization, and then your definition for a hydrate. So a hydrate is a compound that contains water of hydration. In other words, it contains water in the ionic compound structure, okay? And that is what a hydrate is. This is what your formula for a hydrate would look like. Okay, so the ionic compound, and then you can see that the water molecules are attached to the ionic compound, and they are connected by using a dot. Okay, a dot will connect the water molecules to the chemical formula, and that is what the formula of a hydrate looks like. And so what this is telling you, it's a ratio. Okay, see the coefficient 5 here? So that means we have 5 molecules of water for each copper sulfate ion pair. Okay, so it's a ratio. So for every 1 copper sulfate ion pair, there are 5 water molecules surrounding it. Okay, and that is what the hydrate formula is telling us. And we can name these also. I'm not going to test you on naming the hydrates, but you should be able to recognize what a hydrate is. So since there is a coefficient 5, we use our prefix for 5. So then the name is copper 2 sulfate pentahydrate. Okay. Here are some pictures of the copper sulfate and what they look like. So this first picture here is the copper sulfate in the anhydrous state. Anhydrous means that water is not in the structure, so without water. And then when we add water, the solution is blue, okay, when we add water to it. And that is pretty cool about this particular hydrate, is that when water is in the structure, it will change color. And so not all hydrates do that, but it is pretty cool if they do. Now, do you think that I can turn this blue solution back into a white powder? So think about it. So how can I get the water to leave the structure? Well, I could heat it, right? So if I heat it up, the water will evaporate, and then it'll turn it back into this white powder. Okay, now what could I do if I want to turn it back into the blue solution? Add water. So remember the water molecules that are being added here, they're held on by very weak attractive forces. So it's very easy for the water molecules to leave the structure and then to also come back into the structure. Here's what a common question would look like for a hydrate. What is the percent of water in copper sulfate pentahydrate? So this is the type of problem that you definitely need to make sure you know how to do for a test, okay? So it's a percentage problem. So don't forget, any type of percent problem is part over whole, right? Part over whole, and then of course you multiply by 100 to get it into the percent form. So your part, so look at the question. What is the percent of water? So that is our part. So we want to put the water on top, but look at our formula, 5 waters. Okay, so we're going to put the mass of 5 waters on top over the mass of the entire thing, the whole entire structure, okay, part over whole. So then you would need to find the mass of the entire hydrate. Now when you find the mass of this entire hydrate, this dot, once again, is just used as a connector. It does not mean multiply. Okay, do not multiply. You're still just going to add everything up. It's just a connector. It does not mean multiplication. All right, so go ahead and get out your periodic table and find the masses for these. There's a few different ways you can do this. You can add up H2O and then multiply it by 5, or you can multiply the coefficient through. 5 times 2, so that'd be 10 H's, and then 5 O's. So it doesn't matter which way you add it up. Both ways will give you the same answer, okay? And then when you get those masses, then don't forget, you will multiply by 100 to get it into the percent form, okay? So let's see, if you found these masses correctly, 5 waters will give you a mass of 90 grams And then the mass of the whole entire thing, you should have gotten 249.5 grams. And then we're going to multiply by 100. And then that gives us, let's see, you should get 36.1%. Okay, so that is how you solve a hydrate math problem. All right, okay, so that is everything for hydrates and water of hydration, and we will actually do a lab on this in a few days.